Hi, my name is Vincent Conforti, and this is my exam midi video 2 on epistasis. So what is epistasis? In basic terms, it is the interaction of genes. So how one gene is affected by the expression of another, or another way to think about it is that different genotypes have the possibility of producing the same phenotype. Okay, so let's get a little background before we jump into some examples. So there are 6 different modes of epistasis, and each mode or interaction will produce a specific ratio out of 16. So this will make sense in a second. So if you do a dihybrid cross of these two heterozygote individuals, you're going to get these genotypes every time in this given ratio. Notice how they all add up to 16. And so this is when no epistasis is present. But today we're going to be talking about one of the 6 interactions, and it's single recessive. So again, we have our normal ratio, 9, 3, 3, and 1. So our single recessive ratio is going to be 9, 3, and 4. Where do we get that 4 from? Well, these two genotypes, though they're separate, actually produce the same phenotype. So that's why we group them together. Okay, so which genotypes in single recessive produce the same phenotype? And it's going to be little a, big B, and little a, little b. So those are the two genotypes that are going to produce that one phenotype. So let's map this out and look at it in a more visual sense. So for my example, I use the process of building a plane. So in order for a plane to progress throughout its stage of building, it has to have certain factors. It has to have wheels in order to move to the second stage, and it has to get wings to move to the third stage. If it doesn't have wheels, it can't move to that second stage. Let's say it has wheels and it doesn't have wings, well, it can't progress to that third stage, so it's going to stay in that second stage. So let's use actual genotypes to work this problem out. So right here is our normal heterozygote cross, and these are our ratios. So this genotype can move to the second stage because it has a big A and it has a big B, so it can move to the third stage. So therefore, we're going to get a ratio of 9 for this genotype. Okay, and then for our second one, we have big A, so it moves to that second stage, but it's inhibited by those two little b's, and that T-bar shows the inhibition of it moving to the third stage. And you can look over here, and these two genotypes, they don't have big A's, so they can't even move to the second stage, so they're stuck at the color black. Okay, so our last example here is between these two genotypes. So what I did was I crossed big A, little a with just one little a because they're homozygous, and then I did the same with the B's over here. And so these are the combinations I get. So to pick out these ratios, what I had to do was multiply big A, little a times these two squares, and I got these two genotypes in their given ratios. And then I did little a times these two squares, and I got these two ratios. And you notice the pattern is that we're back to our same selective recessive ratio. So thank you for watching my video on epistasis, and these are my references. Have a great night.